Hello and welcome to another lesson on functions, and in today's lesson we will talk about properties of graphs of functions. So let's talk about what an even function is. An even function is simply a function in which when you replace x by negative x in your function and you get your original function back, you say that your function is an even function. For example, if you have f of x is equals to x square and you replace x by negative x in your function and you still get your original function back, you say that you have a even function. Okay, so you see that when we did that, in our case we got x square back. Okay, so we say that x square is a even function. So graphically speaking, so the graph of an even function is symmetric about the y-axis. Okay, so the rule of reflecting over the y-axis is to negate the x coordinate. Okay, if we have f of x comma y, right? So the rule says that we have to negate the x coordinate and leave the y value same. Okay, you will get f of negative x y. Okay, so when you do that, you will have end up with the same curve like this along the y-axis. Okay, okay. So let's talk about what odd functions are. So odd functions are basically those functions that are symmetric about the origin now in this case. Okay, but in terms of its representation, we say that whenever we replace x by negative x and we get negative of our function, we say that our function is an odd function. Okay, for example, if you have f of x is equals to x cube and you replace x by negative x and instead of getting the original function back, you get f of x equal negative f of x, that is our negative x cube, then you say that your function is an odd function. And you see that when we replace x by negative x, we got negative x cube, so negative of our function. That is why we say that x cube is a odd function. So graphically speaking, it is symmetric about the origin. Okay, and for odd function, the rule of rotation by 180 degree about the origin is that we have to replace xy by negative x negative 5. In other terms, you can say that you have to perform the reflection along the x-axis and along the y-axis both. Like if you have this line, you will first reflect it along the y-axis and then reflect it along the x-axis. Okay, so this line will come here and this line will go there. Okay, okay. So let's talk about continuous function and what are different kinds of discontinuity that we see in our functions. Okay, so simply speaking, a continuous function is just a function that does not have any breaks or holes in it. Okay, and if you are drawing them, you can draw them without lifting your pencil. Okay, so this is an example of a continuous function in which you can see that you can easily see that we can draw this function without lifting our pencil, and it has no breaks, no discontinuity in between from this one end to the other end. But in this case, you see that there is some kind of discontinuity in this graph because you cannot draw it without lifting your pencil. You have to first draw the left part and then you have to move on to the right part. Okay, so let's discuss different kind of discontinuities in our graph. We can have a jump discontinuity, we can have a vertical asymptote discontinuity, or we can have a whole discontinuity. Okay, by jump discontinuity we mean that our graph can jump where the value of the function changes quickly. Okay, as we go from one point to another. Okay, or in case of vertical asymptote, basically it is a line that function approaches and it tends to infinity. Okay, this is our vertical asymptote here. Okay, and in case of a hole or a spot, so the graph is basically not defined here. Okay, at this point, so we get a whole discontinuity here. So let's look at a couple of examples to see that what is going on here. Like in this first example, we can see that what kind of a discontinuity do we have? We have a whole discontinuity at x is equals to -1. In the second one, we have some vertical asymptote at x is equals to 1. In the third one, we see that our graph has jumped from this point to this point at x is equals to 1. So we have a jump discontinuity at x is equals to 1. So it is not compulsory that each graph would have one kind of a discontinuity. They can have all kind of discontinuity in the same graph. Like in this case, when you have multiple discontinuity, the best thing is to start from the left and start identifying the discontinuity one by one. So if we start from the left, we see that we have some kind of a jump discontinuity here. We have some asymptote here. We again have some hole here, and we have some jump discontinuity here. Okay, so we can see that we have jump discontinuity at -2 and 4. We have a whole discontinuity at x is equals to 2, and we have a vertical asymptote at x is equals to 0. So for the last one, you can see that we have some kind of a jump discontinuity here and a asymptote here. Okay, so we have a jump discontinuity at x is equals to -1 and a vertical asymptote at x is equals to 2. So let's talk about what is interval of increase and interval of decrease. Okay, so basically the interval within a function's domain where the y values gets larger as you move along the curve. So whenever you have to identify interval of increase or interval of decrease, the simplest way of doing is you start from the left. Okay, and when you start from the left, you see that what is happening to the value of y as you move along the curve. Okay, so as I start from here, okay, I see that what is happening to the value of y. The value of y is increasing, okay, till I get to this point. Okay, and after this point, I can see that now the value of y has started to decrease. Okay, till I get to this end now. Okay, and after this point, what happens is that the value of y again starts to increase. So whenever you have to find the interval of increase or interval of decrease of a function, and you are given in the graph of it, you just have to see what is happening to the value of y. Okay, but so you can easily identify the intervals in which the value of y is increasing and the value of y is decreasing. You can have its interval of increase and its interval of decrease. Okay, so let's look at a couple of an example here, and I'll try to identify different different characteristics. Okay, so the function we are taking is f of x is equals to x. So first of all, we know that this is a identity function and it is a linear function as well. It is a linear function because its degree is 1, and it is an identity function because whatever you plug in for x, you will get it for y. That is why we say that it is an identity function. Okay, so to sketch this graph, what we can do is that you have to make a table of values. You can take any number of values and then you can plot it. Like if your function is y equals to x, in our case, you can take multiple values of x, 0, 1, 2, -1, -2, -3, and your function is y equals to x. You will get 0, 1, 2, -1, -2, and -3 because you have an identity function, and you can just plot these values here. You can plot these points here, and then you can join them by a straight line to sketch this graph. Okay, so let's have a look at its other characteristics now, like domain, range, y-intercept, and x-intercept. So domain are just the input values, range are just the output values. Okay, so our function is f of x equals to x. So domain are those values that your function can take without getting undefined. So you can see that it can take any value and it is not getting undefined at it. Okay, so what is the domain? All the real numbers are its domain. Okay, and what about the range? Now, I told you that this function is an identity function. Okay, so whatever its domain is, the same goes for its range as well. So its range is also real numbers. If you don't want to think it like this, you can think of it like this as well, that range are the output values. It can produce any output value. Whatever you input for it, you get the same output. Okay, that is why its domain and range are the same. For y-intercept, now for y-intercept, you just have to put x is equals to 0 in your function. When you put that, you get 0, 0. Okay, because when x is equals to 0, y equals to 0, and for x-intercept you have to plug in y equals to 0, and when you do that you get 0 0 as well for y-intercept. So let's identify some of the other characteristics like discontinuity, interval of increase, interval of decrease, symmetry, and end behavior. Okay, so if we talk about discontinuity, there is no discontinuity in the graph because we have no holes, we have no breaks, we have no asymptotes here. What about interval of increase and what about interval of decrease? So as we move from left to right, we see that the value of y is always increasing as we move along the graph from left to right. Okay, so it has no interval of decrease, it only has interval of increase. Okay, so it has interval of increase from 0 to infinity. Okay, and interval of decrease is none because it has no interval of decrease. What about the symmetry of the function? It is an odd function or it is an even function, because the symmetry depends on whether it is an odd function or it is an even function. So f of x equals to x. You can easily check by replacing x by negative x, and since we will get negative of our function back, that is why it is an odd function. So what about the end behavior of the function? The end behavior is very simple to identify, that when x tends to infinity, y also tends to infinity. Okay, so as you see the end behavior of the graph, as it moves along like this, the value of x would become bigger and bigger up till infinity, and the value of y become bigger and bigger and bigger up to infinity. Okay, so at the end behavior is the same for both, that when x tends to infinity, y also tends to infinity, and same is the case for the other end as well, that when x tends to negative infinity, y tends to negative infinity. So that's it for today's lesson, and thank you for joining.